we're going to find out today as we go through this whole thing. I'm going to start with the questions and comments people made. We're going to find out a lot of people have a misconception of what science is, of what physics is supposed to be. I mean, you know, I like to give a very simple example. We let go of the spoon. I switch from pens and pencils to spoons, okay? So we let go of the spoon and we realize that falls to the floor. And people have, for the last 10,000 years, have asked those that know more, or people they think know more, right? They asked these people who supposedly are more enlightened, etc. They said, what's causing the spoon to fall to the floor? What's causing the pencil or the pen to fall to the floor? What causes the baby bottle to fall to the floor? And here we are 10,000 years later, and no one can answer that question. And this is incredible, that no one can answer really in a rational manner. By rational, I mean they're going to mediate it with objects, with things, with something, okay? An entity, a body or something. And what they do, they introduce irrelevant concepts, mathematical concepts such as field and energy and mass, which have nothing at all to do with the question being asked. And so this is where it starts. And I want you to see today, you know, based on the questions that people ask or the comments that people made, that is the root of the problem. People are not aware of what science is about, what physics is about. Because the so-called physics we have today, the so-called science we have today, is not geared, is not designed to answer these kinds of questions of what causes a spoon to fall to the floor. And so the question, one of the questions you should ask yourself is this a question of physics? Is physics supposed to answer these types of questions? You know, what causes the spoon to fall to the floor? Is this a question of physics? And, you know, a lot of people out there, especially of the establishment, they argue that this is not a question of physics. That physics is about doing equations, math, measurements, developing technology, winning Nobel Prizes. You know, that's what physics is about. And there's a contradiction there, because when you ask these questions in places like Quora, where, you know, I answer questions there as well, the people who answer are usually physicists or people who consider themselves physicists or study physics or whatever, people who are enthusiasts of physics. And so if physicists are supposed to answer these questions, and they do try to answer these questions, but they answer it with equations instead of giving me a mechanism, then you can see we have a problem, because, you know, the question that I asked does not deserve equations, does not deserve numbers or equations or measurements. I just need a mechanism. You know, just explain the mechanism, we're done. And they cannot explain something as simple as a spoon falling to the floor. That's where we're at today, after hundreds of years, at least, of mathematical physics. By the way, it was Galileo. I think he was the first one to say that the language of the universe, right, being physics, right, explaining how the universe works, the language of the universe is mathematics. And that's where the problem started with people like Galileo and Newton, because they went off on a tangent and they started doing equations, they started doing experiments, and there is no experiment, no equation that can tell you what gravity is, what the mediator of light, of gravity or light for that matter, is. You need to have a mediator, or else you're doing what? Action at a distance. And what is action at a distance? It's the scientific version, scientific with quotations there, right? It's the scientific version of black magic, of witchcraft. That's what action at a distance is. You're saying this affects that over there, and there's nothing in between. And so, yeah, you need to put an object there, a thing there, and that's where the whole thing actually starts, the problem starts. It would have been very easy for them to imagine what could be in that region, and they never did. They just started putting equations and doing it with particles, always with particles. And of course, you cannot simulate, for example, gravity with particles because particles have no way of pulling on each other. Discrete particles, right? And so this is where the problem starts. And so, yeah, math is not going to solve this problem. An experiment is not going to solve this problem. So we don't need experiments. We don't need equations. We do not need any measurements. Okay, none of observation. There's nothing to observe because it's invisible, intangible, whatever's there, right? I mean, here you have the spoon, and when it drops, right, either something's pushing or something is pulling. Something is in contact with the skin of this spoon. And the question is, I need to identify one of these somethings, either what's pushing it or what's pulling it. And they haven't done that. They've never done that. They've always simulated with particles. You can't pull with particles, so they ended up with push gravity, so to speak. And there's another version, which is if you remove the particles here, well, the ones on the top kind of push it inwards, right? So particles is a weird way of doing gravity, and Mother Nature laughs at all particle physicists or particle proponents. So that's where we're at today. It's a big mess. Anyways, I want you to keep that in mind today because we're going to start with one of these folks. He's an aetherist. He's been at least following the lectures for the last 4, 5, 6 weeks. I don't know, maybe longer. And he's a little frustrated with me, and I can understand that because, he won't find answers like mine anywhere on the internet. He's only going to find them here. They're unique answers. They're unique points of view, and it's okay, bring it on. Just cuss my mother. I have no problem. We want to get to the bottom of it. Okay, is there something called the ether? And if there is, tell me what the mechanism is. How the ether produces gravity, light, or whatever you're going to explain, magnetism, any of those. Okay, so let's start with this fellow. Here it is. And this is one of the comments he made in the past. This is one of the first comments. Probably not the first one, but one of the first ones. And he says the following. Okay, he says, you want me to draw the ether? Yeah, I do. I can draw you some kind of medium out of my mind. Okay, just like you drew the ropes. Yeah, there you see a rope. Is that just a drawing? Yeah, it's a drawing of a rope. I mean, maybe someone can draw it better than me. No problem. I'm just saying that light and gravity are mediated by this entity. An entity that looks like a rope. Okay? And light is simply a torsion of that rope. Torsion is the fastest thing known to man. There's nothing faster than torsion in great measure because torsion wave, you could call it, right? Because actually the rope goes nowhere. The rope twirls in place, it torques in situ, and the signal is already at the other end. That's why it's so fast. It beats first longitudinal waves, and not to mention transverse waves, which are even slower than longitudinal waves. And you don't have to believe me. You can look it up and find that during an earthquake, one-dimensional waves travel faster than the two-dimensional waves. Okay, you can look it up on your own. Okay, anyways, he says, that obsession of yours is ridiculous, okay? What will it serve? What it will serve is to find out what your ether is. We need to know what your ether is. You talk as if you knew what it is, and you have a different version of ether than everybody else in the universe. So yeah, we do need to figure out what you mean by the word ether. Either you got to put a definition there, or you have to draw it and show us that it's a physical object if you're going to use it as a thing, in your theory. If you're going to explain a mechanism with ether, we had better know what an ether is. And I'll just give you an example. You're going to explain a motor, an engine of a car. And you say, well, what is an engine? I've never seen one. So you say, that's an engine. You point to it. Okay? Or you say, Johnny threw a rock through the window. I'm going to explain what happened, why that window is broken. And so the person said, here you have the Klingon from another planet. He comes over, says, what's a rock? And so the first thing you do is point to the rock so that you can explain the mechanism. How are you going to explain the mechanism without a thing, right? Mechanism with things, okay? So you need to tell us what the ether is, and he doesn't understand that. And so he's already failed kindergarten physics right there. And he tells us even further, he says, I don't know what the ether looks like. Well, I don't care what God looks like. If you're going to put God, I want to know what your God looks like, your specific God, you know. So I don't care about the general God that everybody believes out there. I want to know what your God, your specific God, what he looks like. You know, if you're going to use God to do something. And here we have the ether. You're going to use the ether to do something. I want to know what your ether looks like. And it was a simple question. Hopefully this is not, rocket science here. We're saying just tell me what your ether looks like so I can visualize your mechanism. That's what it's all about. And then he says, any more than you know what your threads really look like. Well, what do you mean? There's a thread right on the right. It looks more or less like a rubber band. Okay, think of it as the very extremely thin closed loop thread. That's what we're proposing underlies all matter in the universe. Now, how hard is that to visualize? I'm illustrating it for you. So don't tell me that I don't know what my threads look like because I'm illustrating in front of your eyes. Then he says it's all supposed to be invisible and intangible. Remember? Irrelevant. We don't care if it's in God. God can be invisible and intangible. No problem. Just tell me what God looks like when the angels look at him. I want to know what God looks like in your mind. What are you thinking of? What are you visualizing when you think of God? And here's the same thing, with the ether. If you're going to say it's invisible and intangible, no problem. It's irrelevant because an object is not that which is visible or tangible. An object is that which has shape, and hopefully all objects have shape. It's the one and only universal, property of all objects, right? And so you should be able to draw or make a picture of or mock up or something of what you're visualizing when you say ether, if it's a physical object. And it says, do you know what air looks like? And so I gave a couple of examples. One was the astronaut taking a balloon with some gas in it. We can say it's air, right? And he pops it, and we color-coded the air so that you could see it, okay? And that's what it looks like. You see there in the center there, you see the astronaut pop the balloon. And what does air look like? Well, it looks like that blob. That's what it looks like, okay? We don't care what it looks like. We just say it has shape. It's a yes or no question. Does air have shape? Yes, it does, always. And then on the right, you see the air surrounding the Earth, more or less a 3D version of it, okay? And what you see is that air has shell shape around the Earth, more or less. So does air have shape? Yes, it does. Therefore, it is an object. If we remove the Earth, we're going to end up with a hole in there. We find that air has shell shape. So yeah, air does have shape. Hopefully anything made out of atoms has shape. Okay, so anything made out of atoms has shape. In the case of the thread, the one we propose, we're not saying that the thread is made out of atoms. It's the thing that comprises everything else. So you cannot ask, what is the thread made of? Because the thread is fundamental. It's elementary. It makes everything else. Nothing makes the thread. The thread is made of a single piece, okay, and makes up all matter in the universe. That's the assumption. It's known as an assumption, and you have to start with an assumption in physics if you're going to explain a theory, a mechanism, a cause. Okay, so what does this poor fellow say? Well, when I asked him to draw draw the ether, he says, well, not being good at drawing stuff doesn't mean that it doesn't exist. Yeah, he can't draw it, and he says that's because he's no good at drawing. Well, I don't care if he's good at drawing. We just need a sketch, an overall picture of what he thinks the ether is. We're trying to figure out in general terms what the ether is so that he can put it in motion and show us the mechanism of gravity, of light, of electricity, magnetism, whatever. And he says it's all very childish. I guess he thinks all this is just a bunch of word salad, semantics. That's, I guess, the way a lot of these people visualize it. They have all these words, all of just a bunch of noise entering their ears and coming out the other end because there's nothing to stop it in between. And so they don't munch it. They don't crunch it with their teeth and eat it and try to make sense of it. For them, it's just words. It's just noise. And so they feel it's too tedious to deal with definitions. And science is, 150% definitions. If you don't have definitions, we don't understand your theory. So the crucial words, you don't have to define every word in your dissertation, but hopefully the crucial words, the ones that make or break your theory, had better be defined very precisely, okay, so that we can understand what you're talking about. And the objects have to be pointed to. You're going to say rock, tree, dog, house, no problem. Point and name. Ether, point. Energy, point. Field, point. What are you pointing to? A mathematical concept? So again, you need to point and name in order for us to follow the objects that are going to play a role in your theory, right? Okay, so I said to him, essentially, the little aetherist that couldn't, that he was he was unable to tell us what the ether is. And so we can't get to his theory because we're stuck at what it is. And right now we need to make sure that that we understand the word ether so that we can proceed. And right now we can't proceed because we're stuck on this word. And so, he's a little upset about that because I'm insisting on a picture. I want drawing a picture, whatever. I mean, I don't care. Just point to a website. If you want to draw it yourself, no problem. Either way. I mean, he made a video talking about the ether, but at no point did he point to the ether. It says, this is the ether. Now let me tell you my theory. No, he just went directly to the theory. He went to the middle of the movie, and we missed the first part, the important part, where he points on the first frame. That's the ether. That's what I'm going to use for my theory. That's what we need to understand. We're not there yet. We're still stuck. And in case, again, not all etherists agree on what the ether is, and that's the first problem. The other one is no one can define it, no one can tell you what it is. But when everybody draws the luminiferous ether, which is the one they used in the 19th century, the famous, Michelson-Morley experiment on the ether and whether it exists or not, they all thought of the same thing. They were all thinking of a bunch of particles, which is what the Greeks essentially thought of in their minds also when they talked about the ether. They said the ether is the air of the gods. What's air? A bunch of particles that we can't see, that we can't touch, and that's the one for the gods. And so the mathematicians, actually not physicists, but mathematicians of the 19th century, all the way up to the 19th century, were thinking of the ether as a bunch of particles. That's what it was. That's what they were dealing in their mind. Some of them thought of the ether as moving in one direction or in another. Others thought of the ether as being static. No problem. We don't care. It doesn't matter. What is the ether before you move anything? A bunch of particles. That's what it's always been. Here you have a picture. If you can look it up yourself, put the luminiferous ether into Google Images or whatever images, Yahoo, whatever. It doesn't matter. Just do a search engine on it, and here it is. That's what you'll find. You'll find that it's a bunch of particles. Some of them have them moving, all these particles moving, and you can see the arrows pointing downwards in most cases. But they illustrate the ether as a bunch of particles just moving across the solar system. That's what the ether has always been. And so if you have a different idea of what the ether is other than this, right, then your job is to illustrate and tell us what it is, because otherwise we're going to say, no, it's a bunch of particles. You may not like it. You may say, no, it's something else. Okay, tell us what it is. And is it a concept or is it an object? Is it a thing that I can point to with shape, right? Or is it a concept that we have to define, like mass? You can't point to mass. You can't point to energy because they're concepts. And likewise, if the ether is a concept, you can't point to it. You have to define the word and say, this is what I mean by the word ether. No problem. but then you can't use it as a thing. You can't use it in a mechanism. You cannot explain gravity by saying the ether does this, because ether, you have not presented ether as a physical object, as something with shape, right? What you've done is define a word like you would define, energy or field, and none of those words can be used as physical objects in a cause, in a mechanism, okay? And it takes 10 years for a mathematical physicist to understand that. And they keep doing everything with these concepts that they invented. Okay, and so what does this person say? He's angry. He says, you are the one who doesn't understand the damn thing. Yeah, of course I don't understand, because you haven't illustrated the ether. How can I possibly understand if you have not illustrated the ether? And he says that I don't understand the mechanism, right? Especially how, in the case of, for example, the slit experiment, how the particles, because he's going to simulate it with particles, meaning, he means particles by ether, right? He does mean particles, but then he takes it back saying, well, but I don't know what those particles look like. I don't care. Just draw a bunch of particles, cubes, triangles, circles, whatever you want to draw. I don't care. Just draw them. And if there are many particles, then we can't say ether. We have to talk about individual particles. And the issue here is that, he's going to say that he's going to explain the slit experiment by something which is, from another universe, apparently. He's saying the particles are going to turn the corners. That's the problem. And he says, you're the one that doesn't understand the damn thing. Yeah, correctly. I have not understood. You have very simplistic and childish view of particles and reality at that. Well, I don't know how more simplistic you can make particles. Particles is particles is particles. I mean, period. We're done. Particles means a bunch of particles. Grains of sand, you go to the sandbox, you see a bunch of particles, and maybe those are static. Maybe you want particles like air or in the ocean, where you have some currents and, movement of particles. I don't care. I just want you to draw them and show us what you mean. And again, particles is very simplistic. I mean, how much more simpler can you make particles? So I don't know. He says I have a childish view of particles. I don't know how to make it any complicated. Particles is kindergarten stuff. So everybody understands the same thing about particles. What you have to do is draw those particles and show us what you mean by ether before you move anything. You're just like the mathematical physicist. Oh, please. I already explained why light appears to bend around corners. He says he told us. And I said, well, maybe he did. I don't know. Maybe I missed something. And so I went back to find out if I missed something. And no, I didn't. I was sure I didn't miss anything because I was waiting for that answer. But he says he's already told us. Now I won't bother once more because you are either very dumb or you are doing it on purpose or probably both. Okay, so let's find out what he said. This is what he said, of his mechanism, right, for ether. Here it is. And he said, one day, he said the following. He says, take the Poisson spot experiment. The light makes a ring with striations. Okay, why? Because light reflects off the sphere near and from the edge of the circumference, which is curved. Extremely simple and obvious. Yeah, the only problem with what he said there is when you talk about reflection with particles, you're talking about bouncing outwards as shown by the blue arrows. They never go inwards like shown by the red arrows, which is his argument for how the Poisson spot is manufactured. So what we're trying to understand is how does his particle, whatever they may be, right? We don't care what they look like, but we want to know how these discrete particles turn the corner inwards. That's the whole problem. And he doesn't explain that. He says, I have explained it. And what he says is the point in the middle comes from a few inward reflected light rays. He talks about rays, which is an irrational term because we don't know what a ray is. He would have to define that. If you look it up, it's just a bunch of particles traveling in a straight line. And that can't happen if it's turning the corner. That's one issue, it would be curved. But the main point here is that if it hits the edge, it's going to go outwards like shown by the blue arrows. It's not going to go inwards as shown by the red arrows. And so he just continues as if he says he explained it. They are not bent but reflected. Yeah, reflection means they're going to bounce outwards, not inwards. And he cannot show us how they bounce inwards. But he's welcome to go to the lab or, wherever, field, throw a rock against the side of a tree, just hit exactly the edge, and show us how that rock goes inwards instead of bouncing outwards. That's all he's got to do. That's how simple it is. So he hasn't drawn the ether, and he's telling us some irrational nonsense about rocks hitting the edge and bouncing inwards. So yeah, we have a question with both. Okay, first, he needs to draw the ether. He has to show us how the ether does it, or what it looks like first, and then how it does it. How does it get the rock to go inwards instead of outwards? And yeah, he can't answer those questions because he's got irrational proposals. And here, just in case he rubbed it in, he says, light particles explain rectilinear propagation and reflection. Absolutely not, first of all, because those rocks coming from the sun, which they call photons or particles or whatever they want to call them, corpuscles, they come out of every atom in the sun. And if the sun is throwing little particles, they can never, not possibly, under no circumstances travel in a straight line, rectilinear propagation. They will curve because the second one, when it comes out of the atom has already moved, it's spinning, and so has the sun. And so none of the particles will travel in a straight line coming out of one atom. Okay? And then he says, the more you get near the spot where the incident rays, again rays, I don't know what a ray is, reflected angle becomes zero. The reflected rays are now directed towards the screen. Absolutely not. If they're reflected particles, series of particles, they're going to bounce outwards, not inwards. But he says that due to the surface being curved, what we observe is that the rays reflect in many different angles according to the law of reflection. Yeah, many different angles outwards, never inwards. That's the issue. Each reflected ray is making a new dot on the screen. Absolutely not. Not a single one of those particles is hitting the screen. They're hitting the walls of the house on the side. Okay. Some rays are also deflected and diffracted inwards. Absolutely not. Where did he get this? They're diffracted inwards, contributing to the central maxima. And then he said deflections explain bending of light around corners. Yeah, so he hasn't explained how the particles turn the corner. That's what we're trying to understand. And of course, he's frustrated because nobody ever questioned him about that. And there's not much we can do about it. I mean, if the guy insists, well, that's what he's got to believe. He can believe, that God or the angels carry each one of the particles inwards around the obstacle. That's fine. I mean, we don't care about belief. It's got nothing to do with science. We want to understand the mechanism so that we understand what he's proposing. And we're not there yet. So the ball's still in his court if he still wants to address it. Anyways, I thought I'd mention that. Okay, we had other people asking questions or making comments. Here's one. One fellow says, I think it's the same fellow, says, you have no mechanism other than saying the threads are doing this and doing that. Yeah, that's known as a mechanism. When the threads are doing this or doing that, we have in here, we show a mechanism. Here's the mechanism, okay, just in case, okay. We have a rope, okay, you can see the rope. Hopefully I can illustrate everything I say. Okay, we have a rope. We have two atoms. One is the 2D version, the other one is the 3D version. They're doing their quantum jump. They expand and contract, kind of induced by every atom in the universe, which is sending torsion waves through the ropes. Okay, so the rope actually sends signals in both directions, or the torsions propagate in both directions, but the rope essentially stays in place, doesn't go anywhere. I mean, they do move because the atoms move, but the point here is that the ropes are not traveling. It's what we're concerned about when we're talking about light is the signal that is propagating along the rope. And what we have there is the quantum jump, and as the atom expands, it opens the rope a little bit there at the edge where it meets the atom, and that's where the torsion gets generated along the rope and travels to the other atom at the same time. It's traveling to the atom that generated it. In other words, the rope torques in both directions. So there's the mechanism. I'm not sure what part of this he cannot understand when I'm illustrating what I'm saying. Okay, it's just an expansion contraction of the atom, which torques the rope on both ends. And if one pumps a lot faster, well, you have higher frequency. If the other one pumps slower, then you have lower frequency, and that's all there is. So this is baby stuff. This is kindergarten stuff. This is not, again, rocket science, because the rope model brings everything to the understanding of the whole planet, of 8 billion people, unless you have mental problems, you know. But otherwise, everybody should be able to understand the rope model, because it's baby stuff. The universe is baby stuff. It's kindergarten stuff. It's the mathematicians who have made the universe so awesome, so incredibly ununderstandable. And why? Because they did math. And math is very different than physics. Physics is just tell me what objects Mother Nature uses and how she runs the world, or Father Universe, whoever, right? We want to know how the universe works. And hopefully Father Universe, Mother Nature, God, whoever's up there, the devil, they run a very simple universe. It's all rocks and atoms. That's it. And so once you put those in motion, you should be able to explain mechanisms. You do not need to know by how much, by how long, how much time. You know, Mother Nature, Father Universe, they never went to school. They never got an education. They don't know what math is. And it's mathematicians who started making relations and putting numbers to those relations and talking about measurements when the question requires no equations whatsoever, no numbers whatsoever. All you need to do is put physical objects on the screen, and people will understand the mechanism, okay, just by watching. How did the window break? I threw a rock through the window. Oh, let's see, how much force was there? How much energy? How thick was the glass? I don't need to know any of that nonsense. I just need to know the mechanism. The mechanism was rock through window, broke, period. That's the mechanism. And that's how we have to explain gravity. And so he says, how do they spin, twist, and why? Well, why? He's asking a question of philosophy. So he doesn't understand that his question has nothing to do with physics. By why, he's saying who caused it, or by what was the purpose, what was the reason. And those are questions of philosophy, have nothing to do with physics. Physics, we look at mechanism. But then he says, why is there light when they twist? Well, because you have a torsion. Very simple, I just showed it. Yeah. So I don't know what his problem is. You know, you have a torsion along a rope. You can simulate it at home. Take a 2-strand rope, tie it to the walls, right? Put 2 clothespins, one at each end. Move one clothespin, you'll see that the other one moves instantaneously, essentially, instantaneously. You can film it, because I have done that. And you move one, and the other one moves almost instantaneously. Why? Because you have a torsion of the whole rope twisting in situ. That's why. That's the mechanism of light. That's why light is so fast. Okay. It also explains, the links, right? How the bigger the link, the fewer links you have, and the more you torque the rope, the shorter the links, and the more links you have. And that's the equation, the wave equation, which is c, velocity of light, right, equal frequency times wavelength. There you have it. All in very simple, baby stuff, kindergarten stuff. To understand, do you believe it? We don't care. Whether you believe it, whether you're in accord with it, that's got nothing to do with science or with physics. That's religion. What you believe has nothing to do with science. All we do is in science explain the mechanism so that you understand. Okay? So we're not asking you to believe. We're asking you to understand. And people don't understand that. Do you have any idea how many atoms there are in the universe? I've never counted them, sorry. Okay? But I'll do it someday before I die, I guess. It's irrelevant in physics. Who cares how many atoms there are? Do you honestly believe you are being rational by thinking all atoms are physically connected to all other atoms in the universe? Yes. Yeah. In fact, all atoms are physically interconnected. That's why we don't have action at a distance. We have actually an atom affecting another atom through a mediator that cannot be seen or touched. Hopefully, whatever brings this down cannot be seen or touched. Okay, but if you can see it or touch it, then go to the lab and tell me what it looks like. Okay, no, it cannot be seen or touched. So the only way to approach gravity, light, etc., any of these mediators of these phenomena, which we call light, magnetism, gravity, etc., hopefully they're invisible and intangible. Because if you can see the mediator of light, gravity, magnetism, electricity, etc., you've had one beer too many. Okay? No, they are invisible and intangible. So whatever you come up with had better be invisible and intangible, meaning no experiment is going to elucidate its nature. The only way to do it is the way physicists do it. You know, you sit down, you drink a beer, you put your feet on the desk, and you think. You think until you thunk enough, and then you come up with the answer of what you visualize, how Mother Nature could be doing that magic trick. Your atoms would be bigger than stars. I have no idea how you arrived at that conclusion, but again, it shows that fellow doesn't understand kindergarten physics, because right now I'm showing, the mechanism. I've illustrated my atoms. Where does he get the idea that they're bigger than stars? I have no idea. And so he says, it's simply ridiculous, my model. Okay, that's an opinion. Okay? Opinions are not allowed in science and physics. That's religion. Okay, so we don't care about your opinion. We want to know whether you understood the theory, the proposal, the assumptions especially. Okay, another fellow, I think, if we weren't dealing with dictionary definitions or even traditional physics definitions, please define a medium rationally. Yeah, medium, that which has shape. That's what a medium is, okay? People have this notion that medium is something like air or an ocean, and they immediately say, what is the medium made of? They talk about mereology, which is a religion founded by the philosophers, so-called philosophers. They call themselves philosophers. And they say, we came up with mereology, what things are made of. And so they say, that's not a table, that's a trillion atoms. Why? Because the table is made out of a trillion atoms. And that's not an elephant, that's quadrillion atoms. Oh, why is it quadrillion? Because it's made out of quadrillion atoms. So everybody's thinking of, parts of whole, right? And time slices and all this kind of nonsense that the mereologists invented, okay? And they get sidetracked with all this nonsense. And so people have this idea that a medium is something made out of things, out of smaller things. So the sandbox is made out of sand. And so you can't point to the whole sandbox and say, that's a sandbox. Oh, but what is this? Or say sand. They say, well, what is the sand on the beach made of? Well, it's made out of grains. So everybody's immediately partitioning the whole beach into gazillions of grains of sand. They do the same thing with the ocean and with the air. And they say, oh, but the air is made out of many particles, molecules, atoms, whatever, and you can go down to quarks and gluons and whatever. And so it never stops with all these people because they're thinking, what is it made out of? And that's what they think a medium is. It's what it is made out of. That's not what a medium is. Medium is a perfect synonym of the word object for the purposes of physics. Perfect synonym of object, of thing, of something, of anything, of body, of substance. All those words mean exactly the same thing in physics. What is a medium? That which has shape. What is a non-medium? It's known as space. Space is that which does not have shape, otherwise known as nothing, otherwise known as vacuum. You don't want me to describe a medium as a collection of objects. Correct. That's called mereology, and we clean our nose holes with a collection of objects. I'm interested in describing processes and mechanism. Well, in science, we do not describe. We explain. Anybody can describe a chair. Is he a scientist because of that? No, hopefully you explain something. We want to see a mechanism if you're doing physics. I will describe a process. No, you will explain a process. We don't want you to describe it. Because describe is like, I went to the magic show and I saw the magician cut the lady in half. Okay, describe it. Okay, he took a saw, he cut the lady in half, and curtains closed, curtains open, she came out in one piece. That's a description. I still don't know how he made the trick, how he did the trick. Okay? And so this is the issue. We want to know how Mother Nature does the tricks. Now, not tell me that she cut the lady in half and she appeared in one piece. That's a description. We don't care about that. And so, we need to take this fellow back to kindergarten physics and teach him the difference between a description and an explanation. Okay? And here it is, description, a listing of properties of an object. Okay, or you could also say what happened. We call that a narrative or narration. And so when you tell me that the magician cut the lady in half and then she appeared in one piece, that's a narration. All you did was narrate what happened. We call that a narrative, and we still don't know how the trick was done. How the trick was done, explanation. Causes underlying a phenomenon, a physical interpretation, a mechanism underlying a cause to interpret the manner in which a consummated event occurred or happened. So, you need to understand that before you can do physics. And so, this fellow doesn't seem to have gone through kindergarten physics. And that's where he's got to go first before he can come here, because he's obviously behind on news, right? Another fellow says, can you prove what is said here? Well, in science, we don't prove. Prove means I convinced you, I persuaded you, I recruited you, right, into my congregation, to my religion, right? So I was able to prove to you, okay, your neighbor still doesn't believe, but you believe, right? And so I proved to you. So proof is not part of science. It's the mathematicians who introduced the word proof into science, saying, oh, I proved. Oh, how did you prove something? Well, here's the equation. Yeah, 1 + 1 = 2. They call that a proof. Okay, they say, yeah, if you take one apple and buy another apple, that's equal to 2 apples. But those are definitions. Those are, it's a fact that has no place in science per se. That proof. That's just, you have to accept that and say, we're going to call, it's a definition of the word 2, essentially. 2 means 1 + 1. That's all he said. Okay, so we don't care about proofs in science. In science, we have to explain. And so when these people talk about proof, it's because they have this notion that the mathematicians fed to them in high school or college or wherever. So proof just means that we convinced you. The used car salesman was able to sell you the car, right, because you believed it runs perfectly well and whatever. Okay, so that's all that proof means. And another fellow says, more or less along the same line, says, speaking of someone without relevant qualification, okay, we don't care about qualifications here. We don't care if you're, shoeshine boy. It doesn't matter. We don't care. So you have a lot of shoeshine boys that think better than some of the people over there in Cambridge and Harvard, right? So we don't care about your qualifications. And says, root hypothesis. Hypothesis that roots must exist based on their effect on physical objects, despite there being no way to observe them or conduct a test that proves they exist. Again, these people have this notion of proof. No, we don't prove the intangible, invisible, okay? Especially, in fact, you can't even prove the existence of a chair, the chair that I'm sitting on. How am I going to prove existence? Do I sit on the chair and say, see, I've proven that the chair exists because I ran an experiment and I was able to put my butt on the seat of the chair, and that's how I proved that the chair exists? Is that how we do it in science? Is that what you want? You want a proof that the chair exists? How about God? I mean, can we prove that God exists? What do? We sit on God? We throw something at God and see if it bounces back? How do we prove the existence of God? And I mean, if he's invisible and intangible, right? And so again, it's asking for proof is what's wrong, because what people are doing, making an assumption, and we don't prove assumptions. Okay, an assumption is taken for granted; it's taken at face value to understand the theory founded upon it. You don't prove an assumption. You say, "Let us assume that God exists." Now we can proceed and say, "Okay, I'm going to concede the assumption so that I can understand this theory." What's a theory? Well, let me show you how God created the universe or the flower or the bee or whatever. No problem. But first, show me God. And when he shows me God, he says, this is what I think God looks like, or this is what I think God is. This is what I'm going to use God as in my theory. Now I can follow his presentation because I know what he's referring to every time he says God. And the same thing with a rope. I have to say, let us assume there's a rope. And that this rope is what mediates light and gravity, between any two atoms. And so you don't prove it. You make an assumption, and you have to concede the assumption in order to understand the theory that I'm going to tell you. Otherwise, you're not going to understand the theory. Okay? And so these people say, no, let's go to the lab and prove it. Prove to me through an experiment that the rope exists. And it's intangible and invisible, so I'm stuck. You know, it's like, I can't prove it. And nobody can. Nobody can prove that particles exist. Nobody can prove that waves exist. Nobody can prove anything because it's invisible and intangible. You have to make an assumption, and the person listening, has to concede the assumption. And okay, I'll concede your assumption so that I can understand your theory. That's the way science works. These people don't understand science, what I said at the beginning. And then he says, black holes, mathematicians claim they must exist based on their effect on physical objects, despite it being impossible to observe them and requires infinite values of singularity to exist. Yeah, the issue is different here because we're comparing apples and oranges. In the case of a rope, I can illustrate the rope and say, this is what I think, or this is what I propose, right, to be between any two atoms. And you can see the rope and you say, okay, I know what he's talking about because I can see it right there in front of my eyes. Black holes, singularity, which we're going to talk about today, is a non-entity. It's 0D, zero dimensional. It's got no size, no shape. It's got no weight because it's got no mass, because it's got no matter. Because everything in a singularity gets crushed out of existence. It goes into infinity. It's got no energy, no force, no field, no nothing. In fact, a singularity is the definition of nothing. And so that's where we have a difference. They can't put a singularity in front of your eyes and say, this is a singularity. What they usually do is put a point there and to illustrate the singularity, to put a pictorial representation of a singularity, and they put a little dot. And you say, but that's not 0D. That's got 2D at least, maybe 3D, what you put in there. But it's not 0D. And so they say, well, it's just a pictorial representation. Why don't you go through the motions of believing that that's a 0D? Because they cannot illustrate a 0D anything. That's why. So a singularity is not an object. You cannot talk about the existence of a nothing called, a singularity. It has to be an object. It has to have shape. Then you can talk about existence. If God wants to exist, he's got to have shape. If ether wants to exist, it's got to have shape. If the rope wants to exist, it's got to have shape. And if a singularity wants to exist, guess what? And a singularity cannot exist because it has no shape. It's missing the thing or the property that all objects have, which is shape. Okay? And so, yeah, you can't say a singularity exists. It's a mathematical concept. And that's where we are not comparing apples and oranges. We're comparing apples and oranges when you're comparing the rope against a singularity. Okay? The rope we can illustrate. The singularity you cannot. So you cannot talk about the existence of a singularity. Okay, talking about singularity. We're going to move to a definition that we have here. The singularity definition. And this is it. Okay. This is from the Wikipedia. That's why you can see that it's a non-entity. It says, again, you don't have to believe the Wikipedia, okay, but this is what's there, and you'll probably find the same definition elsewhere. In mathematics, a singularity, and by the way, there's no singularity in physics, okay? They never put one. You can look it up, but you won't find the word singularity related to physics. They always relate it to mathematics. Then they use it in physics, but there's no definition of the singularity for the purposes of physics. We're going to look at that. In mathematics, a singularity is a point. Okay, point. What is a point? I guess Euclid's point, 0D, that which has no part, at which a given mathematical object is not defined. Meaning we have infinite numbers. Okay, we've gone to infinity or infinitesimal, one of the two. Or a point where the mathematical object ceases to be well behaved. All these singularities always misbehaving. Why do they do that? Yeah, it's misbehaved. It's not behaved because it's not an entity. It's not a thing. It's just a mathematical concept. So you can't talk about singularities. And here we have fellow who says you would need electric current in a magnet to have those magnetic threads spinning like that. Absolutely, yes you do. And what is he talking about? Well, he's thinking that if we're going to simulate a magnetic field with threads, those threads have to be spinning because the electrons have to be spinning. And that's absolutely what happens. You know, the electrons spin. Here I've illustrated for them. Okay, here you have the row of electron shells, merged electron shells, which we call a serpentine. They swing around, and walls of swinging threads, those are the ones that form the magnetic field. And there you have electric current runs at 90 degrees to the magnetic field. Okay, so here it is one more time. Here you see it. Okay, and so it's that's what's happening with electricity. Okay, electricity is the spinning of an entire serpentine, and you can see that it travels at 90 degrees to the magnetic field, which is consistent with observation. So yeah, a magnetic field, right, it's just a bunch of threads swinging around a region, and that's why they can do electromagnetic force, right, push things around, especially the iron filings, pick them up and do whatever with them. And perpendicular to that, you have electricity running. And again, they don't go anywhere. We don't have little balls, little electron beads flowing from atom to atom, as in quantum mechanics. What you have is really, they're all merged and they're all spinning in situ. And when they do, they swing the threads around. Electricity goes that way, and the field goes at 90 degrees to electricity. And that's what it is. I mean, you had better put a physical object for a magnetic field, because you cannot touch it, you cannot see it, but it has shape. The threads have shape. Okay, each thread has shape. And a bunch of threads form this thing they call field, which is not a thing, it's a concept. Bunch of numbers. They just talk about field as far as the strength of the field, how strong it is at different distances. That's all a field is. Whether it's gravity, electricity, or magnetism, it's all the same. It's just the strength of the field. It's a number followed by a unit. That's what a field is for the purposes of mathematics. It has nothing to do with physics. Physics, we had better have a physical object in that region moving around.